Hello students. Today in this lecture on trees, we will discuss how to insert a new element in BST. Insertion manually you have seen or you will see here again, but today's purpose is to write a program to insert a new element in BST. So let us see how insertion is performed. Here I have taken this example. This is a BST and I want to insert a new element 55. So this 55 I have written in red pen. So you can see here, whenever you want to insert, you always start from root. Here, your new element is 55. So when you compare it with root, you decided to go right because your element is greater than this element. So 55 is greater than 50. So we move to right. Then 55 is smaller than 70. So we move to left. Then 55 is smaller than 60. So we will go left. But left is empty. So 55 is placed here. So what to do? You only always start from root and then move left, right, left, right, left, right, depending upon the value which you want to insert. And then if you find a space or place there, you can insert it. So I read here, I have written. So start from root, move from left to right, depending upon the value to be inserted until you find the space for insertion. So this is the core idea of insertion in BST. Now we will discuss how to write a program for BST. So as I always keep discussing, these are your steps. First you include your files. That means you need stdio.h, conio.h, malloc.h. Then you will declare your structure for a node of a BST. So see here in linked list and stack queue implementation, you have seen only one pointer, but here you will take two pointers, struct node pointer left and struct node pointer right, and there is one information, integer information. So this is how structure of a node for a BST is declared, struct node and then this. So if you have attended all my previous lectures, you will easily understand this, how to take the structure. Now, if you need some global variable, so I'm taking here one global variable root. So struct node pointer root equals to null. So root will be a pointer which will point the root node of your BST. Then the functions. So we are developing only two functions. One is insert function and another is display function. So in display, as we already have discussed, that tree can be traversed in order, pre-order and post-order. So there can be three ways of traversing it. So we can display it in three manners, but I am taking only in order traversal here. So void display in order and struct node pointer is root is passed. So these two functions we are going to use in our program. Therefore, their prototype you can declare before main. In main, you will write menu. I'm not going to discuss here menu again because many a times we have done it. You have written a lot of programs about it. So in every program, you have developed a menu. So how to develop a menu, you can write it. Then you will write a insert function. So how to write this insert function, what is to be written here, that we will discuss in detail. That is what the purpose of this class. So this is the organization of program, how to organize the program. How to insert, that I will discuss later. Then you will display. So we will also write a display function. So this is the how it is organized. We will how to write display, that we will discuss ahead. Okay. Now we come to the point of inserting a new element in BST. So create a new node. Whenever you insert, as you have done in singly linked list, doubly linked list, stack, queue, etc. Whenever you want to insert a new node, you need to create a new node. So how to create that? You all know by writing a memory allocation statement. Memory allocation statement means what? Like you will take a pointer, say struct node pointer ptr equals to null. So this is declaration of pointer. Then you will write ptr equals to struct node pointer in bracket malloc size of. So you know that is what we call the memory allocation statement. So by that allocation statement, you will create a node. Then you will read the data in ptr info. You will put ptr left equals to null, ptr right equals to null. So this is how the node is created. Now after creation of node, you will insert it in BST. So if your BST is empty, that means that root node is empty. Root is null. So if root is null, means tree is empty. In that case, you will write root equals to ptr statement. Root equals to ptr means your node, the new node, is the first node. But if there are already nodes available in your BST, say this, and your new node is ptr, then what to do? As we already have discussed, you will start somewhere from root, then you will move left, right. You will find a place. So how to do that in program? So let us see here. If root is not null, then you take a pointer p equals to p1 equals to root. Why I am taking this? I want to traverse where this new node will go. This new node 55, where it will go. So I want a pointer for that. So while p not null, p1 equals to p means before we will move p. See, p is here, p equals to root, and then we will compare the value, this and the new value, ptr info and this p info. So if this is greater, we will go p equals to p right. Sometimes p will go p equals to p left. So p will move and ultimately it will become null. P1 is following it. So P1 will become pointer for this node 60. Say we want to insert 55. So P will come here on root and we'll see, okay, P is P right because 55 is greater than 50. So P right, here we moved. Then P equals to P left because 55 is smaller than this. So here we moved on 60. Then 60 is greater, this 55 is lesser than 60. So we will move left. Then P will become null. So P will become null, but P1 will be on 60. So for that moment, you are doing this. While P not null, P1 equals to P, you are copying P, value of P into P1 before jumping it. Then you will jump it. So if PTR info, that means this 55 is less than P info, means P is standing somewhere like here. Then P equals to P left. Otherwise, P equals to P right. So what it will do, this loop, P will keep jumping left, right, depending upon value of PTR info and P info. And P1 will follow it. So ultimately P1 will become null and P will become null and P1 will hold the value of this address of the node where this new node is inserted. Now say P1 is here on 60. Now you will check if PTR info is less than P1 info, then P1 left equals to PTR. That means new node is added here, P1 left, because P1 is pointing to 60. So P1 left. So it is added here. Else P1 right equals to PTR. So otherwise, because this node is added on P1 that we have already decided in this loop, now we only are deciding that where to add, left side or right side. So by writing these lines of code, you can add a new element in your BST. So here I have given you the sample code. No, actually this is the code for display. So you will use this code only. This is also in form of a code. So if else you will put, and before I'm releasing this video, many of you have already done it, but those who have not done it can use this code as insertion code, and then you can display it. So how to display the BST? So this is a recursive definition. Recursive definition means it is calling itself. A function when call itself, it is called a recursive function. So display in order struct node pointer r. So initially you will call in your main program, you will call it with root. So root will come here, and then if r is null, then return. Otherwise, what happens in order? Left, root, right. So left. So in order r left, we are calling percentage d r info. So we are displaying the root, and then display in order r right. So these 4 lines of code will be used to display your BST. So I hope that, see here I have mentioned, though you must be in practice of using functions since first year, and you have in C programming you have seen how to call a function, but I still have given you here display in order root. Initially in main you will call like this. So I hope that you are clear now with how to insert a new node in BST, and you will practice it. You will write a program for it. You will create BST. You will insert a new node, and you will display it. Sometimes, from examination point of view, I'm telling you, sometimes a word create is used and insertion word is also used, like code for insertion, code for creation of BST. So when we create, that means user will give n number of nodes initially. Like we will ask how many nodes you want to insert. So if user says I want to insert 5 nodes, then we will insert 5 nodes one after another. So what we can do, create function can call insert function. Only a loop is required. How many nodes you want to insert? So we have already written an insert function. Then what we can do, we can call the insert function again and again for n times, so that the tree is created. In creation, in general, we do it only once. So if tree is already created, then what we do, that we give a message to user that tree is already existing, and we cannot create a new tree. Or otherwise you can also give an option, tree is already there. If you create a new tree, then the previous tree will be destroyed. So in that manner, you can develop the programs. As I already told you many times, that writing a program is a dynamic thing. It's not static like history, that you have learned something. You are learning here how to use a tool. So once you learn how to use a tool, then you can write programs in many different ways. So all the best. Stay happy, stay healthy, and keep reading. So this is about how to insert a new element in BST. Thank you very much.